Okay, so we're all set to graph our function. Again, we're going to use theta as negative pi divided by 4, 0 pi divided by 4, pi divided by 2 and 3/4 pi, and 2, -1, 2, 5, and 2 for our y values. So let's graph it. Okay, so here is my coordinate plane. Now keep in mind that our function is going to start at negative pi divided by 4. And negative pi divided by 4, y is equal to 2. So I'm going to graph that here. And then, when theta is 0, we get -1. So I'm going to graph that there. Again, this is coming from the table of values that we got before. So negative pi divided by 4. And then we have y is 2. When theta is 0, we get y is -1. So just keep those values in mind. Okay, at pi divided by 4, theta was 2. At pi divided by 2, we have 5. Or I should say, at pi divided by 4, y was 2. At pi divided by 2, y is 5. And then at 3/4 pi, we're back at 2. Okay, so here's one period of our new function here. And just let me write that new function. This y is equal to -3 sine of theta, or 2 theta, plus pi divided by 2 plus 2. Okay, so 2 theta, here, let me clear that up. 2 theta plus pi divided by 2 plus 2. And again, these are our table of values that we got making the transformation. So here's our function. Now I could graph another period and just follow the pattern. So this is where it ends. And so at pi, the function is going to be back down at -1. At 5/4 pi, the function would be back up at 2. At 3/2 pi, the function will be at 5. And at 7/4 pi, the function will be back at 2. So here I've graphed 2 periods of the function y is equal to -3 sine of 2 theta plus pi divided by 2 plus 2. I'm going to graph my parent function y is equal to sine theta, just to see how that compares. Okay, so at 0, sine is 0. At pi divided by 2, sine is 1. At pi, sine is 0. At 3/2 pi, sine is -1. And I guess I have to go 8 pi over 4, or 2 pi. And that will get me to the end of the period for regular sine function. So here it is. So this is the regular sine function if I were to graph it. Its period is 2 pi. As you can see, in comparison to our parent function, the function y is equal to -3 sine of 2 theta plus pi divided by 2 plus 2. It's stretched vertically by a factor of 3. It's reflected across the x-axis because we're multiplying by a negative. It's compressed by a factor of 1/2, or a cycling every pi, so it's cycling twice as fast. And we've shifted the function over pi divided by 4 units to the left. Okay, I know that may be a little confusing when you look at it, but as you see, the transformations that we applied and the procedure that we followed is pretty easy. Okay, just remember. Okay, always first isolate what's going on horizontally. Here, we were compressing by a factor of 1/2 for the period is pi, and then we were shifting everything to the left by pi over 4. So we are starting at negative pi over 4, and we're going to end at 3/4 pi. We calculate our theta values, or our new values, and then we apply the transformation to the y. We get our x, or theta, and then we get our y, and then we graph it. So that's the transformation. So just follow that procedure each and every time. Take things one step at a time, and you'll see it's not so bad.